Yeah. All right, that's it. Yeah, no problem. The one I saw, I was getting Huh?
Okay, can you hear me?
Yes, sir.
All right, that's great. Welcome to the class. So we would just kick off from we're gonna go from where we stopped. Hope we are ready. So what have we learned so far? You can tell us what we've learned so far from last week's class. Feel free to unmute your mic and just.
From what we learned so far, hello, can you hear me?
Yes, I can hear you.
Okay. Though I was not in class last week, I was on the road from home, so I didn't get over. I went through the video, and some of the things I was able to pick, though I still need more to be explained.
Sorry, we can't hear Ebenezer.
Bros.
Ebenezer, well done, sir. We can't hear you. Can you speak a little bit?
I'm speaking to the mic.
More louder, please.
Yeah, I'm speaking to the mic. Can you hear me?
Okay, we'll manage.
We can hear you.
Okay, so one of the things that I read through the video was about the supervised learning, how data is being trained, how you put the data into, you train your data and build a model for it, and the output of that model of the trained data will become an input to what you will now use as a model for the unseen data before you now get your final output. Those are the things but I still need more explanation on that. And also the algorithm for each of the both supervised and unsupervised learning. I think I still need more explanation on that.
Okay, so just on that point, we mentioned that the algorithms are not.
Hello?
Yes, can you hear me?
No.
Okay, Okay, so just to answer your question, just on the point of algorithms, we discussed the fact that that's why we are here, obviously, to know which algorithms does what and actually when to use them. Okay, so there is no predefined way of knowing initially what algorithms you're supposed to use. It depends on the business problem. Okay. Anyone else? I'm just trying to connect.
Hello.
Yes. Anyone else?
Yeah, just to nothing much to say. For me, Ebenezer has already summarized basically almost everything we learned last week. Okay, what I would just want to say it's I think the class is getting more technical because because now we are beginning to more like apply the little we've learned from Python. Okay,
Yes.
and I tried going through the uh, Python document for machine learning, this for regression analysis. To be honest, I mean it was like Greek, very much like Greek.
For the regression wonder, okay.
Yeah, the last class, the last
Yeah, the
class.
one that we're going to
Yeah.
cover today, right?
Okay, are we covering it today? Oh, that would be awesome because yes, for the lecture part, it was interesting. At least we learned about the types of learning, machine learning, um, supervised learning, unsupervised learning, and then we enforced. I think
Yeah,
reinforcement learning.
reinforcement learning. Yeah.
Yeah, though you said this course doesn't cover reinforcement learning.
Yeah.
I wish it did anyway. Um, Nevertheless, I think last week was actually very, very interesting.
Okay, that's good. So we're going to continue from where we stopped. I remember I had just finished answering the question that I think it was Tola that raised the question about what algorithm should we use, which is exactly what has been raised now. And I said it depends on the business problem. So I also sent out all these things that I was basically our class, right? The PowerPoint things I was writing down on our board. Um, I send them out to Ross, right, on our base camp, and I wanted us to look at it. So, and I also have mentioned several. Maybe I probably won't say it again, but basically, come prepared. Come to take notes. If you are taking the notes on your laptop, if you are taking it on a physical note, just come ready to take notes like your normal class in school, in your physical school in back home. Okay, so that when I'm writing, you can also write something. But eventually, I will send us what we've learned. So if I can share my screen, let me see. Okay, we stopped at simple linear regression. Let me share my screen. Okay, so this is where we stopped last time. So what do we understand from simple linear regression? What have we? Okay. Okay. So we talked about the problem. So if you have so this simple linear regression is the gateway to other more technical things that we'll be seeing as the class progresses. Okay, so that's why we normally start here. Okay, because even oh, okay. So other machine learning aspects would in one way or the other make reference to some kind of linear stuff. Even the support vector machine that we'll look at, there is a linear case and non-linear case to it. deep learning, as you know it, with neural networks, the initial problem is how can we start, learn something that can easily be classified by a linear perceptron and all that. So it's kind of the gateway to other more technical things. So I'm sure we have this side, and I told us to have a look at this book, Introduction to Statistical Learning, which from time to time I'll be making reference to. I'm going to start on a new slide for today, and which I will send out to us after the class. So this was the business problem. So let's start from here. Okay, so we've done our recap of what we've covered from our last class, and I hope you cannot see my screen. Okay, and we are now in the section of we're going to cover this. Hopefully we'll cover all this today and do some examples with our Jupyter notebooks. So getting introduced to simple linear regression and multiple linear regression, where are they used, and also polynomial regression. And from there, we'll continue to progress to other more technical things. So simple linear regression, let's continue. Simple linear regression. So we mentioned a scenario where you had to predict. By now we know what regression and classification is. Okay, classification, you are predicting categorical variables. For instance, if somebody will have cancer or not. Okay, or if you had 3 kinds of cancer, or 3, let's say, good, better, and best, for instance, those kind of categorical examples. That's for classification. But for regression, your goal is numerical outputs. Okay, so in this case, you have a typical example, housing prices, where you are to predict the price of a house based on the size. So that's the output, or the dependent variable is going to be numerical outcomes. Okay. So we had our equation. So that's why it's good to have some, at least start now to refresh on some maths, because that's where the background all begins. We had an equation, y is b0 plus, say, b1 times x1, okay? And okay, who can show us which one is the dependent variable and which one is independent variable?
Why is the dependent variable?
Okay, that's correct. And which
From
one is
the
it?
equation.
Sorry?
I said from the equation, it's obvious that y is the dependent variable, because without the values of I think the intercept, bo plus b1, and then times x1. X1 is the independent variable.
Awesome. Okay, that's very good. So just a quick refresh on that. Yeah. So for those that will be reading this later, let's just make that very obvious. So y is the dependent variable. I hope we won't forget what dv means. Okay, and that's why it's good to be in the. So, and this x is our independent variable. Okay, let me just write out this one very well. So the dependent variable is basically something that you are trying to explain. All right, something we are trying to explain. So independent variable. Okay. So something we're trying to explain. So for instance, that's prices, okay? The housing prices, for instance, and the X is independent variable, the thing that causes dependent variable to change. So example, the size of the house, okay? And then this our B0 is the intercept, okay? Basically the value of Y when X is 0, okay? So that is our intercept, and then B1 is our coefficient. Okay. So just to proceed. So I did plot something in the last lecture. What was it?
Hello, sir.
Okay. Yes.
Sorry that kind of interjecting or interrupting the class right now.
Mhm.
I downloaded an introduction to statistical learning. Okay, but it's written, I don't know if it's the same one you're talking about, to say with applications in R.
Yes. That's the one. Yeah.
That's the one.
Yeah.
Okay. I have it, so maybe I'll just share it with others on the Telegram group then.
All right. Yes. Yeah. That's good. Okay. So we did an example, like we said, housing prices, but our data that we're going to be looking at contains something on contains something around salary and experience. Okay, so let's have that. We have that we want to predict some salary given some experience. So years of experience. Okay. Now, as we will see in the later part of our class, as we go down, where simple linear regression obviously would be very nice is that our data have some kind of linear correlation. Okay, if you look at this distribution here, let me minimize this section. Okay. Yeah. If we look at this distribution here, we can see that there is some kind of linear projection. It's as if when salary is increasing, when the y-axis is increasing, the x-axis is also increasing. Okay, so there's some kind of linear dependence between the data, and more formally, we can just write it out as, so from this equation here, we can deduce that salary is equal to our intercept plus our coefficient times this experience. Okay, so this is how we progress with other things that we'll be deriving later on in this class. So it could just be anything. It could be increase in sales versus TV advertising, for instance. It could be increase in housing prices versus the size of the house, etc. This our graph here, or this chart here, we can see that obviously a straight line can fit through the data. You know, we can be able to draw some kind of straight line, and then this our intercept, this our constant, is obviously where it meets with the vertical axis. So for instance, if it crosses, let's say 20,000, okay, let's say our intercept is here. Okay, let me draw this more properly. So if it crosses somewhere, okay, but you get the idea. Okay, if our line crosses, let's say like this, and this is this area, let's say this is 40,000, this is 30,000, this point is 20,000, this is, let's say, 25, for instance. Okay, so at this point where, at this particular point where we have that intersection, we can interpret it as with no experience. Obviously, this is years of experience. So this is obviously 0, 1, 2, 3, etc. If this is 0 years, 1 year, 2 years, experience in years. Okay. So we can interpret this as with no experience, your minimum salary, annual salary now should be like, say, £20,000. Okay, so from here.
Hello, sir, doctor. Sorry.
Yes.
Hello, sir. Sorry, please. I want to find out something. I want to understand something. How do we know where to draw our line from? Because I could see that you drew the line from 20. Why is it not drawn from the point where?
Okay. This is just that's a good question. This is still just an explanation. Okay, this line is our model, which we would see in our Python section. Okay, so this is our model. All right, with our data, we can generate this model and use it for the prediction. Okay, so it may not be here. It may not always start from here and all that. But basically, we're trying to explain that the linear model, this our function here, is what we are going to use to make predictions. Okay, and at the point where if we have this kind of point where it crosses, it could cross, let's say here, maybe 10,000 and all that, but we're trying to get the interpretation of what this simple linear regression is doing. Okay, yeah, so the interpretation, if we have that our line, this line of best fit, which is our model, and the point where it crosses the y-axis, the interpretation of it is that is the point where with zero experience, for instance, assuming it crosses here, okay, that's the least point. Okay, so from here, obviously, if you project from here, for somebody with 1 year experience, maybe should be earning 25,000. Somebody with 2 years experience should be earning maybe 30,000, and so forth. Okay, I suppose we've seen this kind of thing before.
Sorry, maybe you didn't get my question, sir. I'm trying to understand the point, the starting point of where the line is being drawn. You know, as the case is now, it starts from 20. Now, I'm kind of like saying, why not?
It's an example. It can start from anywhere. Yeah.
Okay.
It
So
can start,
that place is the point of interception, right?
yes, it can start from here. Let me clean this one. It can start from here. It depends on your data. Okay? It mostly starts from 20. It's an example. I'm just explaining the whole concept of simple linear regression. Okay? We will see more from the actual data. It depends on the data. Do you understand? So the point where it meets this y-axis is based on your data. Your data set. Yes. It's not an arbitrary choice.
Okay.
Okay. That's good. So we could have it that it started from here as well. Okay, and this is our model. Okay. So I'm trying to say that the interpretation, when you have your model that way, the interpretation is that when x is 0, as we can see here. The x-axis is 0. The y-axis here is 25,000. The interpretation is that with 0 years of experience, you can start earning from £25,000. With 1 year of experience, you can maybe start earning from, according to this model here, from, let's say, 28,000, for instance, etc. But we'll see this in the code with real data, and we'll make the interpretations thereof. We'll continue with the interpretation. Okay. So we can, let me make another. A new slide. Okay. So let me draw it out more clearly. I think we've managed to explain that. So with an increase in years here, with an increase in experience, okay, from 1 to 2, there is a corresponding increase in salary. That's basically what this whole model is doing. Okay. I hope that is clear. That's just what this model is doing. It's a straight line model, and it's simply saying that as salary increases, so if your salary has increased from, sorry, if your experience has increased from 1 year to 2 years, according to this straight line model here, you can start earning from £30,000. But we'll see more details from a live example with our data. Okay, so that's it for that. So how do we then find the best line? Because the question is, how do we draw this line? Okay, the question is, how does this model, how does a simple linear regression actually know where to best start? Okay, how does it fit in to the data most appropriately, if I'll say it that way? Okay, the simple linear regression finds, the model finds a line. Let me write it here. So it finds, simple linear regression finds the line with the minimum sum of squares. And I'll explain that in a bit. Finds the line with the minimum sum of squares. Okay, so what does that mean? And that's, so that line is the best fitting line. Okay, so that line is the best fitting line. So what do we mean by that? So back to our salary and experience. So again, we have, say, salary here and experience. Okay, so let's say we have our data points as we saw before. We have one here. So this is our data point, etc. And then we have this line that goes through. We have this line that goes through the data. Okay. So there is a distance between each point and the line. Okay, let's say here. This is the distance between that point and this line. There is this distance, this one as well. So each point has a distance. Each point in the line has a distance, okay? So you can call this, so this is the prediction line. Our straight line here is the prediction line, okay? So let's call that, it's normally called y hat, okay? So this is our y, this points here. So our y of I, okay? So each of these is our normal data point, okay? Y of I, where I is the point of each of these data sets, or each of these data points, okay? So that's our Y of I. And then our line is our line, so Y of I, our data points, and then our Y of I hat. Okay, if you look at the text, for instance, this is how you can explain it. Our Y hat is the predicted value by the model. Okay, so basically, if this was again 1 year, 2 years, 3 years, 4 years, 5 years, for instance, and this was 10,000, 20,000, 30,000, 40,000, 50,000, etc. Okay. Our prediction line tells us, for instance, that the person with 1 year experience should be earning, which pen should I use now? Okay. The person with 1 year experience should be earning somewhere here, let's say 25,000. Okay, that's our prediction line. Okay, so this is our yi is, sorry, y hat is the predicted value by the model. So predicted value by our model. Okay, to find the best line which answers the question, to find where exactly that line should be in order to be the best fitting line, the simple linear regression will simply calculate the sum of y, each of the y minus y hat squared. Okay, it will find the minimum. So it will try to find the minimum of this. So take, for instance, if we had, if this data, if this yi of this one, now remember that yi is for each of these. So how many i's do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So for each of these data points, this point minus this point, don't know if you can see my cursor.
We can't see it, sir.
You can't see it, right? Let me, where is this thing? Okay, can you see anything on the screen?
We can only see the what you are writing, but we can't see your cursor.
Okay. I will find out how I can put the laser thing to this, so that you can see where I am where the pen is moving at.
Hello, sir. What if you click on the select option? Will that help? I think probably because you're
This one,
selected the pen. Sorry?
which select option?
Towards underneath file, towards your left, yes.
Okay. Okay, no, this one. Okay, can you see this thing moving around? Okay.
Yes, we can see that now.
Yes, we can see it.
Okay, but it's not going to allow me to
navigate and type.
Yeah, I am looking for.
Maybe you need to go back to the drop those.
There's one that is like a laser that moves around with the pen.
Okay.
I will find it. Don't worry. I'll find it later. But let's just continue. So, is there anything on the screen that you can see?
Just
You
the
can
right.
see your mouse.
Just the graph and what you've written. We can't see your mouse.
There's no. Okay.
No.
All right. Okay. Okay. Don't worry. By next class, I would find out. I know we have a laser point, but actually, okay, no, it's not gonna show. It's not gonna show. I have a presenter, but that is for a physical class. Don't worry. I know I've done this before because I've been using this for a while.
I would suggest maybe you switch between the selector and the pen anytime. It might just take a little time, just in case you want to show us anything.
Or let me try. Actually, let me see if okay. I think it's here. Let me show. Laser pointer. Okay, can you see something now?
Yes, we can.
Yes.
Okay, so you can see something moving around.
Yes, we can.
That's that. I won't.
Okay, let's mute our mics. But then when this pointer is on, it doesn't allow me to write. That's just the thing. All right.
Look at pen on the second list. Maybe to allow you pen. Yep.
Okay, can you see this red thing moving around?
Yes.
Okay. Oh, okay, you can see it, right? Oh, yeah, that's okay, that's cool. Right, that probably should make it better. Okay, so
Can it be both then so that it will?
Sorry?
I said, can you increase the size as in to bold it so that it will be more obvious?
It will be bigger, right? I'm not sure. I'm not sure I can do that now, but don't worry. I will sort it out by next class. What I'm gonna do is to go back to the slide that we had before. Yeah, let me go back to here, and we're just going to continue. I would try and because this one allows me to. This one allows me to write at the same time, but it's just that the. Okay. On the other hand, I have mouse here, so I can use both of them to show you exactly. You can see the mouse, right? Can you see the mouse moving around?
Yes.
Yes.
Yeah. Okay. Okay, that's fine. So I can use the mouse to move around and explain or show you something directly. Okay, I think that's better. Okay. So what I was trying to explain is this point here, the point between each the data point for each of our data sets, this distance between here and here is simply what simple linear regression is trying to do. Okay, so this yi for let's start from here. For this one, this data point minus this value here, y hat, the predicted line, the yi minus that, and then squared, and then the sum of all of each of this. So we have 12. When you do this one, for instance, you end up with 12 in the minimum of each one. Okay, so for each of these, that's what the simple linear regression is just trying to find, the minimum sum of squares. So when we sum each one, okay, when we sum yi minus this squared, we keep doing it, and then we just find the line that has the minimum value. That's simply what the simple linear regression is trying to do. And that will become the line of best fit. In statistics, it's called ordinary least squares method. So OLS, ordinary least squares. That's simply what it's trying to do. And we're going to see examples in our Python class.
So,
Yes.
ordinary what?
Ordinary least squares. Okay. Sorry.
Oh, okay.
Yeah.
And then, sorry, I just want to understand this explanation. Can we use the figure that we have right now to explain for us? So, like, let's say the point, the very first one is at 40, right? So you're saying you minus 20 from 40 because the line is.
So this, you can see that it's a positive.
So that one, let's say that is on 40, right? The red one above is on 40, and then the line underneath is 20. So we take 20 from 40, and then we do the square root of 20, right?
So no, what it's trying to say is this: that the predicted value. Let's assume that the predicted value is 15, and from this data point, let's say it will not be 40 minus 15, then it will be 30 minus 15, 20 minus 15, 10 minus 15. By the time we had all those numbers, we will now sum everything together and square it. That is our ordinary least square method. I call it the line of fitted line.
Yeah. So that's just simply it. It's really so simple. It's really so simple, but the explanation as well is fairly simple. But then there are so many assumptions which we are coming to, okay, which makes simple linear regression one of the simplest models to use. And maybe you probably may not be using it so much in practice, but it's very good to understand the basics of how other better models, let's say, kicked off from. Okay, because that was.
Hello, doctor.
Yes.
Okay, I need to clarify some facts. You talked about the data points here. We have two data points. One at the top, the higher the one at the maximum, the one minimum, and the predicted line falls in between. So if we are to look for the difference, why are we considering the maximum value and not the minimum value? Why are we just picking randomly, or what is inferring our decision to get in our line of best fits?
What is the final decision?
What is inferring our decision to pick data point? Why are we picking the one because we have two data points here. We have one
no. Data point. No. The data points are your data set. So let me show us. Let me show us. So how many of us ran the Jupyter notebook that we sent last week? Who was able to go through the?
I flipped through it. I just flipped.
I went through it, but I didn't understand it, so I had to leave it till we get to the class.
All right. Okay. So let's just look at an example. Okay. So I think okay. So this is what we sent last week. Can you see this? I think it's quite small. How do I increase the font size again? Okay. Let me try and increase the font size.
That is a doctor.
Yes, you can see it now, right?
Yes. This is the simple linear regression that you sent to us.
Exactly. So this is how your data is, for instance. Okay. And then the salary point is on the it's on the x-axis. Okay. So this salary point rather is on the y-axis, and then this experience is on the x-axis. We can see it, right? So over here we have our salary and years of experience. When you plot a portion of that data, for instance, when you plot a portion, you will have that where salary was, in this case, that's 9,343. Years of experience was 1.1. Okay. So when you plot that, when you do a scatter plot, of that experience and salary, and here is 1 year, 2 years, or from this our data here. Okay, so here we have increments of 1.1, 1.3, 1.5, 2. Okay, so depending on the scale, so here could be, this is 1, this is 1.5, this is 2, this is 2.5, 3, etc. Right? So if you plot 1.1 years versus 39,000, so 1.1 will be somewhere here, right? Let me move so somewhere here, right? And then if this was 0, and then here is 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, etc. Okay. Now 1.1 years versus 39,000 will be somewhere here. That becomes the first data point. And then we'll come back here, 1.3 years and 46,000. 1.3 years is somewhere around the middle here, somewhere here, and 46,000. So somewhere, let's say around this region. Okay, so that's how you will plot, do your scatter plots, and then that's how this thing I'm doing here came about. Do you understand? If that was your data. But now that we have a real data, we can plot this and actually see. Okay?
Okay, doctor, sorry. From this that you've just done now, if we are to start the drawing of the line, where will it start from?
So, so that's the line is the predicted line. The
Yes,
line.
I know. Where will we start from the drawing now?
So that's it depends on your line of best fit. Do you understand? So okay, we've seen for instance, this line here starts from here. That is the predicted line versus the data. Okay, when you have trained your model. Okay, so let's actually come over to, so if you have your Jupyter notebook, open it now, so that we can have a look at our simple linear regression. So before we go over to multiple linear regression and then explain some more things in detail. Okay, so now that we are done with, now that we are done with simple linear regression, we explained that this is the goal of the algorithm. It's not really an algorithm, it's just a function. Okay, an algorithm is how steps or procedures that you take in achieving a result. Okay, so this is the step and a one-line equation step that we take to achieve our prediction. Okay, so let's go over to the Jupyter notebook and then try to understand this in more detail, because from there we'll begin to understand what other machine learning models do. Remember, we said in the last class that the goal of machine learning is to learn from data. So when you plot that data point, it has not learned anything. You cannot predict anything, okay, with that data point the way it was. But when you've trained a model, in this case, a linear model, that model, okay, we said this last week. So when you've trained a model, so this here is an example of a linear model, right? When you trained a model and then you now use it on your test set, you can then make prediction. So the graph or the thing that you are seeing is based on prediction, assuming that line was the line of best fit. Okay. So let's come over here and do some more practice. Do we have any other question? Okay, let me explain this and then we can ask our other questions that we may have. So if you have your this our data here, you can load it in. This is basically it's just our, let me run this. Okay. So when we import, first of all, we start by importing libraries. I suppose this is our first, okay. This is our file, but we've seen some of this during the pandas class, right? Nothing is new here. That's why we did the pandas class and the Python class, okay? So nothing is really new here. Here we are simply reading, we are importing NumPy as NP, we are importing matplotlib, which is the Python's default plotting library, and we're importing pandas, which is a library for data analysis in Python. This next line here is simply reading in the data. Okay. So your own will be different because I have stored my data sets in a data set directory. So if you are working off the same directory, if you are putting everything in one directory, say called machine learning, then you probably don't need this bit here. Okay. I don't know if that makes sense. Yeah, okay. So if everything that you are working with is in one directory, you don't need this, you just need, let me clarify that. You just need, you only need this section.
You only need the name of the file.
Exactly, just the name of the file like this, okay? So I think that one is clear. Okay, so once we've loaded the data, we print out the data. We call the data set to show us what the data looks like.
Hello, sir. I didn't get that part. You were explaining that if you have one directory, you don't need to do what?
If this file is on Basecamp, right? If you are putting everything, if this Jupyter notebook and this file are in the same folder, you don't need this data sets section, this line here. Do you understand? You just need to call the file like this. Is that clear?
Okay, sir.
Okay. Okay, so this is our data. There are about 30 data points there. And it's simply years of experience and salary. That's it. This 0123 is Python's default row numbering. It would just show you the number of your rows starting from index 0 all the way to the last one.
Can we call that label in Python?
Sorry?
Can we call that label in Python?
No, this is default. This is just default. Okay, that's just the default, okay? Okay, so this is how the data looks like, okay? So the first thing that you want to do, okay, so remember that X is the independent variable. Our independent variable is our years of experience, and we are trying to predict salary, okay? So we want to select our X. So this thing means without the last column, okay? So there are two ways to select this data, as you have seen in your pandas class. Either you select, this is index 0 and index 1 here. Okay, so either you select index 1 directly. So yeah, so here we are selecting everything except the last column. For our dependent variable, we are selecting, I hope you remember what this means. This means the whole row and this salary column. So 0, 1. Okay, remember it's 0, 1. Okay, so that's what here is selecting. And then this one here means without the last column. So basically this, basically years of experience. Okay. So that's our X. So that's how we select our X. Our X is our years of experience, and then our Y is our salary. Okay, so let's run that. And if you want, you can check again. You can make another cell. So I'll use this plus sign to just add a cell here. If you want to see what X looks like, you can type X here and see that it's actually an array of this our years of experience column. Okay. And then you can do the same for Y. You can put Y, and we see that it's an array, a vector array of these of the salaries. Okay. So what's the next thing? So Y is yeah, as we can see here, it's a vector, an array vector containing our salaries. So the next thing is to do what we've learned in our theory. Okay, to do this thing here. Okay, so we're going to divide the data into training and testing. Okay, we will train with this training data, this side here, so that the model, we will get a learned model, or so that the model will learn from the data. And then we would use that model feeding testing data set, which has not been shown to the model before. Something, a data set that is different, separated from this training set. We'll fit it into the model, and then we'll make our prediction. So this block diagram here is what we are implementing in the code. So what is going on here? The scikit-learn library called sklearn contains so many modules and functions in Python for us to do data science with on machine learning. Okay, so you can manually do this yourself, or you can import a function that will do it for you. So in this case, we're importing this function. Is called train test split. We're importing it from sklearn.model selection. And as you know, Python is open source, right? So every year, these things are improved upon. So last year, as at last year with Python 3.5, this thing here was called cross-validation. Okay, it was called cross-validation, but now it's called model_selection. So as a data scientist, you also have to keep abreast with updated changes, but that's for later. So this train test split is the function that will enable us to split the data into training sections and test sections. So we'll have our X train and Y train, and then we'll have our X test and Y test. So remember, our X is our independent variable. So essentially, we want to split this data. So we are splitting it into 1/3. Okay, so let me show us what is going on under the hood. So you can check, like we've seen before, you can check for yourself what is actually going on. Model_selection, import train test splits. Okay. So if you want to know what is contained in that function, like we said, you can use your shift and tab to actually find out within Jupyter Notebook the parameters that that function takes. So if you expand on it, you will see the various parameters that it takes. It's looking for a test size and a train size, as well as a random state. Okay, so tests size. So we'll pass in our x and y, which we have created here. Our x and our y. We'll pass them in here, and then we pass test size. So we want 1/3 of the data to be used for testing. That section will not be used for training. So this thing is going to keep it aside. It's going to assign it to this X test and Y test. And then want a random state to basically be 1, 2, 3. It could be anything. You could call it 4, 5, 6 and all that. It's basically a random number generator that will make your work reproducible. So each time, if I run this equation now with this random state, if I remove this random state, every time I run the equation, every time I run this function rather, I will get something different, because this function randomly splits the data between training and testing in order to make the model good. Okay. So, but
I didn't get that. Sorry, doctor.
Okay.
I needed to explain it again.
All right. So let me write it here. So by default,
I'm sorry, sir. Maybe I should first of all ask, how did we arrive at splitting our data to 1/3? What exactly are we trying to achieve?
What we're trying to achieve is supervised learning, right? Supervised learning, you train your data, you have a section of your data that you use to train the machine learning algorithm. And then you have a section that you use to test the algorithm, right? That's what we're trying to achieve. So,
hello, sir.
Yes.
Can we call it sample testing? Like you're just taking a sample out of the available data to run.
It's different from we are randomly shuffling the data, basically.
Okay.
Okay, we are just shuffling the data. I will show.
I want to find out something. Now, we are doing 1/3 of the data.
Mm-hmm.
Now, and we set the random states to 1, 2, 3.
Mm-hmm.
I'm still trying to get confused. Now, can mine decide to want to say, okay, I want to do 1/5 of the data and set the
okay
state to 7, 8, 9. So can we just choose it?
Okay, let me answer them one after. Yeah, let me answer them one after the other. So first of all, random states enable source. Let me write it in your note that I will send you. Okay, so that we'll remember it. The random state, if I can. So random states. I hope we all remember this. Okay, so let me explain it this way, without the random states, you will get a different result each time you run that function. Okay, so each time you run this line here, each time you run this line, you will get something different. Let's do it actually. Let's do it so that we can see it in action. So let's remove this random state. Okay, so to answer the second question, you need more data for your training set because you want your algorithm to learn something good, right? So you can't use, say, 1/5 for training and 4/5 for testing. Do you understand? You always need more for training and less for your testing. Okay, so let me write it again in your notes. You always need more data for the training set. By now, you know that training set is the part of the data used to train the algorithm. Okay, you always need more data for the training set and less data for your test set. Okay, so training set.
Doctor,
Yes.
what I'm assuming, we have the data set we have now is 30 number. Let's assume that I'm having a 10 million data that I need to, so we list, what I'm trying to write, what is the minimum and what's the standard, the minimum and the maximum?
Okay, yes. So let me write one for, there's no predefined standard. Okay, there's no predefined standard. So training set used to train the model. So this is what is recommended in terms of machine learning practice. Okay, you can have, so let me test sets. Let me put this in your notes so that now that the question is test sets used to check how well the model performed. Okay. Let's say rule of thumb. Yeah. Rule of thumb. So how do we split these things? In practice, you can have 60% for training. Oops. 60% for training, and then 40% for testing. You can have,
answered my question, sir.
Yeah, you can have 75% for training and 25% for testing. You can also have 80% for training and 20% for testing. Okay. So in this particular instance, we are having 66% because 66%, 1/3 is 33%, right? So the other 66% is for training. Okay. So what we're trying to test, we're trying to check the random split something. So let's run this. So let me show us what is going on exactly. So the X train is the part of our X, our independent variable used for training. So our independent variable is this years of experience now, right? We're trying to predict this. So this is our independent variable. So we can see that it has shuffled the data. Not only shuffled it, it has selected 66%. So how many? 1/3 if you remove 1/3 from 30, so this is 20 now. So it has selected 20 for our training. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it has selected 20 for our X train and kept 10 for our X test. So let's see X test. Oops. X underscore tests. So this is the 10 for testing, right? This is what it's going to use to check after the model has learned something. It's going to use this one to make the prediction. Okay. So let's see what happens when this is our X train, right? Let's run this again and see what X train will look like. Let's make another cell. So if we run this again, X underscore train, you can see it's slightly different from this one. So this was 4.1. This is now 4. This was 1.1. This is now 7.1. Do you get it now? This was 4.9. This is now 3.7. So it has shuffled the data randomly. Okay. So it means that you will get different results, but still the same model. It's still the same train model, but it's shuffling the data because there shouldn't be any bias in machine learning algorithms. I will still come to bias and variance and all that. Okay. So, but that's the reason why we put that random state there. So if we put a random underscore random state, right? Random states. Oh, randoms underscore states equals to, let's say, 1, 2, 3, or you can call it 4, 5, 6. You can call it whatever you want, even 2 or 45, whatever. That is simply a random number generator within Python. It's going to use that random number generator, the same one that you specified will be used every time. So now we have our X train as this. When we run this same thing again, we will still have that our X train is still, you can see 2.2 and 2.2, 1.5 and 1.5. This thing makes our work consistent. If you, after 10 years, when you are looking at this code, you will still get the same results, get the same plot. As when you plotted something, you will still get the same plot. Everything will be the same. That's why we use random state for reproducible work. Okay, so random state is for reproducibility. Okay, just to make our work consistent all the time. Right. So now that we've seen what the data sets look like, train, test, Y train, and Y test, we can go ahead to begin to fit the model. Okay, so sorry for the noise. So from this same iScaleLearn library, we're going to import linear regression. Okay, so linear regression is a module in Python Every R has it. I think every other MATLAB and every other one has got a linear regression function. Okay, so we're going to import the linear regression, and the first thing that we want to do after importing the linear regression module for us to use in doing the work is to make a regressor object. So you want to, when you call this function, you are basically creating a regressor object that you would then use to fit to your training set, to your X train and to your Y train. Okay, so remember this name can be anything. Okay, you mustn't be called regressor. The naming of your variables in your code, you can call it what you want. So it mustn't be called this. You can, but what we recommend is something intuitive, so that when someone is reading your code, the person understands what is going on. Okay, I can decide to call it RE, or maybe RE may not make much sense, you know, and then you continue with the RE here and RE here and every other place that RE appears. Okay, so here we just call the regressor object, and let's see what goes on. So we've assigned it to this regressor here. So there are many, again, Shift and Tab. There are various parameters that object can take. Okay, there are various parameters that it can take, but most importantly, it can take the fit method. There are many methods that it can take. So you can see you can make a copy of it, you can do fit, you can fit an intercept, you can do normalize, you can do predict, and all that. So for training our data, we need the fit method. For predicting, we need the predict method. Okay. So here we are training or fitting the model on our training set. That model is expecting, fit linear model is expecting X and Y values. And we're going to pass our X train and our Y train. Okay. So this is simply the training. Okay. This is this line here is this here, is this one here. Okay. The data is being fit, or is the data is being trained. Okay. So that line represents this section where we are fitting a model to the data, or the data is being fit to the model. Okay. And then this section here that we are predicting on the test set represents this section here that we saw during the theory. Okay, so what is going on? Now that we've done the fit method on the regressor, so use the fit method to fit the regressor to the training set. The next thing is to use it to predict on.
Hello, sir.
Yes.
Yeah, sorry. Can I take you back a bit?
Okay.
Now, what does the fit function really do? When you say fit, how do you mean by fit?
It's basically doing that equation. Okay, it's basically taking is basically taking this data and running through this our, where is it? Running through this our
linear regression equation.
exactly.
Okay.
It's performing linear regression. That's what it's
Okay.
yeah.
Okay. Okay.
As simple as that. Yeah. So that fit function is performing linear regression on the training data. Okay, the X and Y, our independent and dependent variables.
Doctor, but the output here.
So, yeah, so what it gives you is the method, all right? So,
Hello, doctor. Hello, sir.
Yes, yes.
Hello. Hello, doctor.
Yes, I can hear you.
Yeah, this output here, the result fits like that show linear regression. Hello.
Yes, what is the question?
Hello.
What is your question?
Hello. Hello.
What is your question?
I said the output for the regression. Can you hear me?
I think he's having network issues.
Hello, sir. Can you hear me? Hello. Hello.
I really can't hear you very well. But I think I understood. You are asking what the output is. This is simply the output of the fit method. Okay? That is simply the output of the fit method from the fit function. So for instance, if you type regressor here, that is the method. Do you understand? This is the output of, this is what is going on in the background. It's a linear regression. It's giving you the default parameters. Number of jobs is 1, normalization is false, fit intercept is true because we want to fit the intercept and we want to copy our X value over to what we want to do. For instance, our predict. If you don't copy, if this is not true, you won't be able to predict on this test set. Okay, so that's just the output of the function. Okay. So the next part is this section to predict with the testing data. Okay, this is the unseen data that was not used for the training. Okay, so this thing is the model. It has learned something. This regressor object contains, remember, a model is just learned parameters. Okay, it has learned the coefficients. Where is our model has learned what it has simply learned these coefficients and this intercept. So when you now bring a fresh data, it just fits this new data and then the resulting outcome will be your Y. That's all. That's for simple linear regression.
Can you repeat yourself, please?
Okay, so the model is learned coefficients, learned parameters. Okay, in this case, our simple linear regression model, it has learned the coefficient and the intercept as well. Okay, so that when so this is our learned model. It has learned these parameters, it has learned our B0 and B1, and it has found the minimum sum of squares has performed ordinary least squares, and it is holding the value of the best line or the best model at this time. Okay, so we would look at it. We would, I think maybe in our next class, we will actually see how to manually implement these things, in case you are interested in the manual implementation. Okay, we will look at them. We will look at how this function works in more detail.
I think the manual
you
implementation.
understand the manual. If we can explain the manual,
Yeah,
I think it would be easier to understand all these things you're working out, because I'm a bit lost somewhere.
okay. We'll explain the manual details of
I totally agree with Tola. I think the manual, understanding the manual will go a long way to helping us understand how this works.
Yeah, we'll do it. Okay. We'll do it.
Yeah. Good evening, Mr. Rinde.
Yes, who is that?
This is Richard. I just wanted to ask a quick question. I don't know whether it's the right time.
Okay.
Yeah, based on the diagram that you drew,
this one.
This one and the other one, the other proper diagram, the one is got the model. Yeah. This one.
Okay.
Can I say that the y of 1, if you go back to that diagram, and can I say the y of 1 is not constant because it has to be based on the predicted model? The y of 1, which is this one, is not a constant, right? It will be based on the predicted model, which was in that other diagram.
This red dot here?
No, the y of 1, the line. Yeah, the y of I, sorry, the y of I here.
Yeah, it's based on the predicted. So this plot.
So it's not constant because of the predicted model, isn't it? Which
yes. It depends on the predicted model. Yes.
Yeah. Okay. Awesome. Thank you.
Okay. All right. So once we've done the let's complete this section and then we can take more questions. Okay. So once we've done our training, which is what we did here, we've trained it, the model. We can now perform prediction on the test set. Okay, and this is our. So let's look at our test set. What is in our test set? Our test set simply contains. Our test set simply contains these 10 values of our years of experience. I want to predict the salary. Okay. So when we call the predict function, then we are simply making the prediction using the trained model. Okay, using our trained model, and then basically these values will simply be predicted values of the salary. So this YPRED are simply predicted values from, that's our trained model, and we can print out those values. And when we kind of compare between our test and our actual value and the predicted value, we can see that there are at least some similarities. Okay, so the Y test is the value that was not seen by the data, which is this first part here. And then these are let me print them out. Okay, so they are different now because we've changed our this thing. So this first part here, the actual value was 83,000. Let's just call it 83,000. But our predicted value is 74,000. The next one was 56,000, but our predicted value is 62,000. Okay, the next one, 46,000, and then predicted value is really way off, and something thousand. Okay, so we can visualize the results. We can visualize the results using a scatter plot. So the thing that you've been seeing here is actually visualization of our results when we have had a trained model. Okay, so let's visualize on the training data set. Remember, the training data set is the one that we trained with. And then we'll also visualize on our test data. So let's look at it on our training data. So this PLT here is obviously from our matplotlib function. Okay. So that's the plotting library in Python. Okay. So basically, we want to do a scatter plot, and then want to look at our training data. So our X train, our Y train, and we can select color to be red. So for these dots, you can choose blue or orange or any color that you want. So we're going to plot our train. We're going to plot. So for this line, so this, let me explain what's going on. So this first plot here is just going to plot, this one here is just going to plot these dots. Okay, these red dots here. That's what this line here is doing. This next one here is going to plot this line. Okay, so this plot here is for the line. This scatter plot here is for this dots here. Okay, and then we can choose. So this is the value of our training data. Okay, we can call it from this our predict function here. We can choose a blue. We can put black there, or let me put black for instance. Okay. So this is the value on the training data, but we are more interested, obviously, in the test data to know how good the model performed. Okay, so let's see how it's performed on the test data. So right now we are changing the values to the test set, and then we are plotting our trained regressor. Okay, our prediction is still this line, but we want to see it on the test set. Remember, our test set is just 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there's another one here, 10. Okay, so that's what this plot is doing. Okay. Okay, so this thing here represents this thing I've been drawing since. Okay, and this line is the best fitting line that shows how good our model has performed. Okay, so we can see here that it didn't start. We don't really have any y-intercept actually. If the line continued, if the line continued, we won't have. So we can, from here, if you project for, let's say, for this point here, let's look at the values again. Let's look at X tests and Y tests. X underscore tests. Okay. So at say 5.3 years. So let's say somewhere here. And then let's look at the Y. Y underscore tests. Okay. So from our, if we, can we see my pen? Oh, okay, I can't write on this. But basically, you can make from this model that let's let's say for 6 years. For 6 years, you can trace this line and you can see that we have a prediction around 70-something thousand. And that's, we can fit in for each individual values. What we would do is when we see when we look at our next class, let's say when we do for polynomial regression, we can actually fit for we can actually fit for each individual line. So let's do prediction for each one. Let me show you. Let's predict for, let's do prediction for, so regressor.predict. Let's predict for, let's look at our data and see what we can. So from our data, 6.6 years is supposed to be 93,000. 6 years is supposed to be 93,000. Let's see what we have. Okay, so our prediction here says that 6 years will give us 81,000. So it's not obviously very accurate, but it's not too far as well. Okay. From our tests, from our actual data set, let's say 10.3 years is supposed to give us 122,000. Let's see how our model did. 10.3. Okay, so that was actually quite correct. 120. Yeah, so it's for this 10 years we get around 123,000. So it did fairly well. So you can use the model. So assuming you are now, the whole aim of this exercise is how can we predict salary based on years of experience? And here, and you are giving some data to build a model. You have built a model, okay? And then your model is telling you that someone with 10 years of experience should be earning 119,000 pounds, for instance. And it's not actually too far off from the truth if we were to work it out manually. It's not actually too far off from the truth. So you can use that model to perform other predictions, and you will not be too far off from the actual value or the actual truth. Okay, so that is one step done. The other step is to look at multiple linear regression. So what if we have more than one variable? So let's go back to our slide. Okay, so ask who has a question.
Hello, sir.
Yes.
Yes, sir. Please, from the predictions we did now, I can see that the values we are testing for fall between the range of the test values also. For example, I see the highest value there is 10.3. That's from the Python plot we did just now. But can we use it to predict for a value maybe like 12 years, someone with 12 years or 12 years experience?
Exactly.
Or
So
13 years
that's the
experience?
aim. Yeah, exactly. So let me go back to, hold on a sec. Yeah, so if we go back to here, we can predict for someone that has 12 years of experience, and we can see that we should be paying that person 138,000 pounds. So that is it's a linear model that salary is linearly dependent on experience. Okay. So 13 years experience should be 148,000 according to this model. Okay. So that's the goal of machine learning, to learn something so that when you have new data, you can make a prediction. Okay. And it will not be too far.
Hello, sir.
Yes.
Our predicted results, can it be can we conclude that it is the line of best fit, or?
Yeah, this our model here, this line is the line of best fit in terms of linear regression terminologies.
Okay, so so we can say it's from your first lectures where you were trying to show us the manual, the statistical manual.
I can't hear you again. Sorry, we can't hear you. Don't worry. Let's continue. So what we will do is obviously post your questions to the forum. I will answer, or even your colleagues can answer, just like someone answered today. Okay, but we have performed our first machine learning prediction today successfully, and it was a very simple, very simple linear model where we only have one independent variable called years of experience, and we have an outcome that we're trying to predict, salary. And we have seen from our model that we can use it to make some fairly good predictions that, based on the trained model, we can predict for someone with 10 years experience, and our model tells us the person should be earning 119,596 pounds. So that's kind of a summary. The next part is, what if you want to consider years of experience plus education, qualifications or certifications, plus what else? Maybe the kind of places the person has worked in or something like that. Or in the case of housing prices, you are no longer considering just the size of the house, but also the location, also the age of the house, and some other parameters or variables. When you have multiple variables, how do we handle such instances? So that would simply be from the same linear regression, but again having various independent variables. Now we now have more than one independent variable. So for multiple linear regression, multiple linear regression is basically the same as simple linear regression, but you now have many variables. Like I said, you have other things to consider in your model, whatever model it is, whatever the business case is. So here, the business case, so let me, let's make up a business case. I could make up, let's say we have, let's say we're trying to actually predict profit. So again, this I've already posted this on the base camp already. If you want to predict profit,
can you please check the chat?
Sorry?
Can you please check your chat? I think people are chatting.
Oh. Okay. Oh, okay. Oh, sorry. I haven't been looking at the chat. Oh, sorry. So the first one, what is Y hat? This is simply called Y hat. Y hat. Normalize equals false. Let me go back. Normalize equals false simply means you're not performing data normalization. Okay, we learned about data normalization before in our last class. Where was it? Learned about data normalization, basically putting our data in the same scale. I think we did all that the last time. Yeah. So here we talked about, this was discretization. Yeah, data normalization, expressing the data in the same scale. So that is what we are not normalizing the data. That's what normalize equals false means. Okay, so yes, we'll do the manual part. We will sum up, we would write, it's going to be fairly long. We will do it in our next class and have to gradually understand what exactly is going on behind the scenes and how much the scikit-learn library has actually abstracted things for us. Okay, so we'll go through that, or I can actually send us that with the assignment, let's say over the week, and you can have a play at it yourself. Okay. So, but in terms of simple linear regression, that equation is what is just going on in the background. But then there is the computation of the line of best fit, the ordinary least squares computation as part of it. And then we only get the result of a class, which helps us to fit or make prediction from our data. We need to interpret the model using the results we got. Interpret the model. Yes, so if I'm getting you clearly, if I can get you correctly, our model using the result that we got. So our results, the result that we have is we just did it here. Okay, we have a trained model that we can use to make prediction. This regressor contains our trained object. When we called the fit method here on the training set, basically we got our trained model. We got this point. Okay, this is what we did. And we call the fit method, and then that object contains, that object also contains the function, the predict function that you can use to make your prediction, which is what we called here. Here's basically what we called here. And you can predict for 5 years, and what you will get is, say, 72,000. And you can check how far off you are from the actual values. So these are the actual values. These red dots are actual values of your data, while this line is the line of best fit, the prediction line. So if you run so that's what I was trying to draw out here. So if you run these are the actual values of our data, and then this line is the prediction line. So if your data, this is experience and this is salary. Okay. So if this was 1 year, 2 years, 3 years, etc. If this data point here was, if this data point was corresponding to 10 years, for instance, then, sorry, correspond to £10,000, then, so this is for 1 year, then this prediction line is saying that the person should be earning maybe £12,000. So that's the difference. So it's not too far from the actual values of your data, of your test data. Okay. So let me summarize. These points here are actual values of our test set. So remember, the test set is the set that the data has not seen. Sorry, the model has not seen. Okay. And then this line here is the line of best fit, our regression model. We will see other models as we progress. Okay. And what we are learning is when the value is, say, 100,000, right, for 8 years, thereabouts. Let me see. If it's 100, so if this, so let's look at our, where's our X test, yeah? So this is our X test. So this value here, this 8.2 here corresponds to 113,000. Okay, so 113,000 for 8.2 years. But our model also says we should, so sorry, 113,000, yes. But our model says 102,000. So our model is not, it's a few thousands away from the actual truth or the actual, a good prediction. So it's not going to get it accurate. It's not going to get it 100%. Otherwise, it's not machine learning. If your data will still come to other terminologies of underfitting and overfitting. Okay, but this is just a good starting point for us to learn how we perform training and testing using some actual data. So in our next class, we will look at, or maybe even before then, like I said, I can send you what we can have a look at before our next class. And then I would like us to follow up with, I will send us some slides for multiple linear regression. Is basically the same as simple linear regression, but now you have multiple values for your independent variable. So like here we have profit to predict, and then you have these ones. You have what you spent on research and development, what you spent on administration or marketing, or this is for a company. And your goal as data scientist is to predict what the profit of that company would be. You will be wondering what this state here is doing. These are the states where this data was generated from, for instance. And if we had the time, we were supposed to cover it in this class about dummy variables, but I will send us the slides anyway to help us with the explanation, so that when we come for the next class, we would have some things to learn from. Now, based on what we've learned so far, I would like us to, I will give, the assignment was meant to be, now the simple assignments here before, but I'm going to give assignment based on what we have learned so far. Okay, so that you can put this to practice and internalize what you've learned today. We're meant to cover multiple linear regression and also polynomial regression today. So I will give an assignment. Okay, I will send us the assignment by tomorrow based on what we've done today, and then I'll be looking out for your questions on the discussion forum. Any final question? Any final question before we go? Okay, I hope at least it was clear. I tried to explain what was going on, and then, like I said, we would look at it in more detail in terms of the actual underlying codes and what this function is doing. This not that one. This linear regression function is actually doing. We'll look at it and then give examples as well. But we'll give assignment based on this one so that you would get to practice on this and start getting your hands dirty, really, because if you miss one point, you're going to get an error. So you need to also start to fix errors that will come up definitely in your code as they arise. I know we are still doing some more Python training, but the more you do it, the more you get into errors, the more you learn how the thing works. For instance, selecting your own data and doing your own trend test splits. All right, so that's it for today. I'll see us in the next class. I'll find out when exactly our next class would be, if we are on holiday next week or so, I don't know. But I'll see us in the next class, and look out for the assignment and other explanations.
Thank you, sir. Good night.
Okay, good night.
Good night, sir.
Good night, Doctor.
Okay, good night.